Okay, find the length of the hypotenuse. I've included in here our little special rate triangle for 45, 45, 90 because I want to just illustrate what it is that we do with it. Okay, if you're given the leg, and we are given this leg as 3 root 2, you can see that we take the leg over here, x, and we multiply it by the square root of 2 in order to get the hypotenuse. So if we're looking for the length of the hypotenuse, we need to take this leg length, which of course they're both the same because it's an isosceles right triangle. We are going to take that 3 root 2 and we were going to say the x root 2 that we know the hypotenuse of a 45, 45, 90 triangle is equal to needs to be equal to, well, in this case, what is x? X is 3 root 2. And we need to multiply that. This part is x. That's here. And let me underline it in a different color. Okay. This is what x is. And now we need to also put in there the root 2 right there as root 2. And then we will find the length of the hypotenuse, x root 2, is equal to, and what you need to see is that this is 3 times root 2 times root 2, and this part, root 2, times this part, root 2. What is root 2 times root 2? You got it, it's 2. And that's getting multiplied by 3. So x root 2, what the hypotenuse is 6. Yeah? Essentially, if you took the leg and you multiply it by root 2, you get a 2 for the two roots multiplied together times the 3 is the 6. Now, for problem 7, they're telling you it's a 45, 45, 90, and they're telling you that the leg is 10. Find BC, which is the hypotenuse. So what do you do with the leg length, also known as x? You multiply it by root 2 in order to get the hypotenuse. So if it's already 10, we're going to multiply that by root 2 and get 10 root 2, and the units is feet. That couldn't be simpler. That's A. Now for number 8, this could be a little bit trickier. Notice that it says for choice A, it says root 3. Root 3 is never going to play into the 45, 45, 90s. Okay? It might incidentally appear as if for some reason of the numbers that we use, but you're not using it. You're probably not going to see it. So what do we do? Well, this is an interesting one. We need to set 24, the length of the hypotenuse, equal to what we know the hypotenuse is equal to over here on the special right triangle. It's equal to x root 2. And if it's equal to x root 2, we set it equal to x root 2. And once we do that, we say we're going to solve this by, you got it, dividing both sides by the square root of 2. Why do we do that? Because we want this to cancel out, leaving you with just x. And what you get is 24 over square root of 2. Now I'm going to do this over on the side. You need to resolve this. You need to rationalize the denominator. And how do you do that? You multiply by whatever radical is in the denominator. The radical that's in the denominator is root 2. Okay, so doing that, you get on top 24 root 2 over root 2 times root 2 is 2. And notice that those two numbers can be simplified. 24 divided by 2 becomes 12 times that root 2, 12 root 2. And as you can see, that's D. Now, before we're done with this problem, we know it's D, but before we're done with this problem, I'm going to show you the shortcut of this. And I'm going to explain why it works. And let's do it up top. We'll do it in orange because give you a fresh color to see. If you were given a whole number hypotenuse length, okay, then the quick trick is to cut it in half to 12 and stick a root 2 on it. That. Interesting. Well, why is that the case? What's going on there? Well, what's going on there is really this. If you said we need x root 2 to equal 24, well, wouldn't it be really convenient if we're going to divide both sides by root 2 if this 24 was written in such a way that there was a root 2 to be canceled out? Well, we can do that. We can say this. 24 is just the same as 12 times 2, right? 12 times 2 is 24. And we could further write that as 12 times, how do we break 2 up? We break 2 up into root 2 times root 2 because we know root 2 times root 2 is equal to 2. So we could write the 2 as root 2 times root 2. Okay. Then if you had x root 2 equals 12 times root 2 times root 2, and you divided both sides by root 2, in order to cancel it there, you have to divide this right-hand side by root 2 as well, and you cancel it, one of them. And then what do you have that's left? You have an x equals 12 root 2. Okay? So the quick trick is to take whatever the hypotenuse is, if it's a whole number, and divide it by 2 and put a root 2 after it. And if it can be simplified when you divide it by 2, like 24 divided by 2 can be 12, then you simplify it. If it was an odd number, it wouldn't simplify. That's it.